Welcome Year 8, it's forces, waves and generating electricity. This is lesson number 8, waves. You can see here the surfer is riding a water wave, and you can see the young boy is generating sound waves using his loudspeaker. And the sun emits light and heat waves. It keeps us alive. What I'd like you to do is draw a diagram of what a wave looks like to you in this box here. Now, many of you will draw a wave like a typical water wave, something like that. Or you may have drawn a wave like this. You may even have drawn a hand waving like so. Or maybe some of you are thinking about a pond and throwing a pebble into the pond and looking at the pond from above. You're almost like a bird, and you'll see that the stone hits the water and then the ripples move out. They radiate out in all directions, etc., etc., etc. So let's move on. Waves allow energy to travel from one place to another. Waves travel from one place to another. For both diagrams, name what emits the waves. Well, it's the boy. The boy emits or gives off sound waves. The type of energy waves given off. He gives off bum, bum, bum. Sound waves are given off. And what senses the waves? The person's ear senses the sound waves. Or rather, what actually happens is the sound waves are funneled into the ear, and they then pass through and cause your tiniest bones in your body to vibrate. There's 3 of them, an anvil, a stirrup, and another one, I can't remember what its name is, and they vibrate, and then those vibrations are passed on to your auditory nerve, which then links up to your brain, and your brain makes sense of those sound waves. It's really quite amazing. You have a go at number 2 for both diagrams. Name what emits the waves. Well, what emits the waves is the fire. The types of energy waves it gives off not only light but heat. And what senses those waves? Well, the light waves are sensed by this person's eyes, whereas the heat waves are sensed by your skin. Now, your teacher is going to use a slinky spring to show you the 2 basic types of waves. These waves are, science words now, transverse and longitudinal waves. Let's have a look at a video on this.
Hey guys, I just want to demonstrate the 2 types of waves using a slinky and my son Dane and my daughter Riley over to the left. So the first wave is called a longitudinal wave, and it's like a pulse going through the slinky. And this is how sound waves move. So Dane, can you do a longitudinal wave? Whoa, beautiful. Do a quick one. Whoa, you could totally see it coming back and forth. That was really cool. So that's a pulse. That's a longitudinal wave, just like sound waves. Okay, Riley on the left is going to do what's called a transverse wave. In a transverse wave, the wave is going to move this way, but the motion of the wave is going to be up and down, perpendicular to the motion of the wave. Okay, Riley, do a transverse wave. Beautiful. Oh, that was a really good one. Perfect. Okay, I hope that helps you guys.
Okay, so there's these two types of waves. Let's have a look at transverse first. Transverse waves. They're waves from a slinky spring. They're typical surf waves, water waves, light and heat and microwaves and radio waves. They are all types of transverse waves. They move up and down and up and down and up and down. Now, the movement of the energy is in this direction. But in order for this wave to be generated, notice the lady has to move her hands at right angles. Now, in the video, the talker said perpendicular. It's exactly the same. It's at right angles. It's at 90 degrees. The movement of the hand, the oscillations, is at 90 degrees to the movement of the energy. Now, let's move on to longitudinal waves. Slinky spring waves can be longitudinal, and the speaker said sound waves can be longitudinal as well. So let's just have a look at this. Now, this hand here is going to move backwards and forwards and backwards and forwards. So the oscillations, the movements are backwards and forwards, backwards and forwards. And the movement of the energy is in the same direction. So you can see an example here. This is sound waves. The loudspeaker is going to move in and out and in and out. And that is going to cause air particles to move backwards and forwards, backwards and forwards, backwards and forwards like this, and knock into each other, knock into each other, knock into each other, knock into each other, and then they're going to be funneled down the ear. These two circles are called a Venn diagram. I'm going to pause this for a second and colour in the segments. Now, the way a Venn diagram works is as follows. The green section here, the green section, that represents only longitudinal waves. The blue section here, that only represents transverse waves. Now this section in the middle, the yellow section, means any waves that can be both longitudinal and transverse. So we're going to do the blue ones first. These are the transverse waves. You put these into the blue section. So microwaves, you're going to write that in here. What else have we got? Surfing waves, light and heat waves. Yeah, they're all transverse waves. Radio waves as well. Now, longitudinal waves. The one that's left that is only longitudinal, that'll be sound. And so, what type of waves can be both transverse or longitudinal? The yellow ones, that'll be the slinky spring waves. Fill this in. Now here we have a wave diagram. It's one wave in actual fact. And I'd like you to be able to understand how to measure the wavelength and the amplitude. Now, the length of one wave, and we've got one complete wave here. To work that out, I'm going to use a ruler. So, if I wanted to work out the length of this wave, I would do this, okay? I'd put in a line here. I go to the end of the wave. I put a line in here as well. Come on, my pretty. There we go. And now I use my ruler to measure this distance right here. You use a ruler to measure the wavelength, and I think you're going to put in the wavelength not only in centimeters but in millimeters as well, so you need to use a ruler to measure that. Then let us measure the amplitude of this. The amplitude. Now the amplitude is from this dotted line here, where there is no displacement, up to the top of the peak or all the way down to the bottom of the trough. It doesn't matter which one you pick, they'll both be the same distance. I'll do both in actual fact. So we've got this distance right here. That's the measurement for the amplitude. And this is also a measurement for the amplitude. Now, once again, you'll be writing in, you'll be measuring that amplitude and putting it in centimeters and in millimeters as well. Now, just to give you a flavor of sound waves, right? If you've got a very small amplitude, it's going to be a very quiet sound. Whereas if you increase your voice levels, the amplitude's going to go up as well. What? And then, ooh, quiet again. If the wavelength is very, 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 very small, then the sound will be high. Whereas if the wavelength increases, gets longer, then the sound wave will be much deeper. Anyway, wavelength and amplitude, really important in physics. We'll come across that again in Key Stage 4. So that's GCSE standard, this stuff. And that is it for today. What you could do is look online and see if you can't get a signal generator. Have a look online and see if you can't find a signal generator to generate sounds and then increase the wavelength, increase the amplitude. So the wavelength increasing, amplitude is increasing here and decreasing, and see if you can't find out a little about wavelengths and amplitude. online anyway. See you next time.